Going to look here at the same type of question, which seems to come up fairly regularly, where we are asked to come up with a combination of ADTs to model a slightly complicated situation. As with all these videos, pause, make sure you read things beforehand. I've included part A just so you can see the context, but part A is really not that important here, so we can focus our attention on part B. Now let's consider this first attempt. There's the priority queue, which is based exclusively on whether or not the plane is local. Now, straight away, that's wrong because we know that the priority needs to be based on all of these factors. We're told not to actually try and work out what the priority is. And the way this has been set up, the air traffic controllers can only see the most recent, or the highest priority plane. So this is no good. Have a look at this response. So instead of just basing the priority on the local or not, we've based it on a combination of all the things. We're not going to try and design that. We're explicitly told not to. But this is still wrong. So we've got to read the question again. The air traffic controller needs to efficiently access all of this information about every aeroplane in order to make that decision themselves. So our ADT should not contain any kind of calculated priority. It should just contain the information needed for the air traffic controller to make their decision. At times like this, it's helpful to try and put yourself in the position of an air traffic controller, if you can manage that. You've got a heap of planes in the sky. I guess you probably know their flight numbers, and you want to work out which one's going to land next. And so you need to be able to quickly type in their flight number and retrieve all of this information. And we're interested in quick retrieval. We're probably thinking about dictionaries. If you want quick retrieval of not just one, but of any of the things that are in front of us, we're probably going to start with a dictionary. Let's have a think about this one. So the air traffic controller can certainly quickly look up any particular flight and get all the information they need. So we've answered the first part of the question. However, we haven't justified it. So now we've got to say very carefully, why does this work? So we've said here explicitly, and we've said it's in constant time, that we can look up the array for any given flight, and then we can look up whichever particular value we need about any given flight, about any property of that flight. So that response as it was, I think, should have got all the marks. Now, they've given us a extra bit in, so the first bit was my writing, but it's pretty much the same as the definitive response in the examiner's report. They've also told us what we could then do after we have calculated the priority. So we take each plane, we work out its priority using the ADTs we have worked out. The bit in italics tells you what to then do with that priority, which personally I think is unnecessary. I don't think that has been asked for in the question, but look, whenever they give these responses in the report, they're not always like, this is the best response, or you have to do everything in this response to get the marks. But the key thing is to make sure we've met the efficiency requirement. We've done it in a way that makes sense for the person who's like doing the job. So for example, we don't just need to know like the next local plane that's coming in. We need to be able to see all the planes so we can make our calculation. And we've explicitly justified it. And we've used in that justification words like constant time or linear time, depending on which ADT we've used. Here's a question I came up with. I'm not hugely proud or hugely ashamed of it. I think it's got some valuable stuff we can learn. So pause, have a go, see what you think. Okay, what do we think of this response? I feel like people sometimes just dive in and go, like, let's just pick two things and mash them together. Dictionaries are often good, and it's nice in this response that we've given an example. So we've got how the system of dictionaries works, so it's clear to the examiner. Unfortunately, in this case, that would make it clear that it's definitely wrong because we're told it has to be able to be looked up quickly according to the ISBN and the author's name. And for this, we would have to, if we want to find all the books by J.K. Rowling, we would have to go through the dictionary, print out or access every single book, and check the author's name. So that would be incredibly inefficient. It's also inefficient because we've used like these same keys over and over to store like author, title, and category. Like we know what those things are, so there's no need to store them as like headings in an Excel file. Okay, so that's definitely not a very good response. And I think the key here is that we need to be able to look up both by ISBN and by author's name. And for that to work, we're going to need two dictionaries, aren't we? So that's probably a good starting point. So we've got our first dictionary, which allows us to look up by ISBN and Mr. Square bracket there. And we haven't got all the extraneous information like the repeated keys, author in every single one. Then we need another dictionary, which allows us to go from an author to all the books. So that is going to be a dictionary of lists. It would have to be a dictionary of lists because we know that one author can have any number of books. We've assumed that the author's names are unique. So now we've got to justify this. Well, let's just think about how that's going to work. We can obviously, looking up by the ISBN is pretty straightforward. If we wanted to find all the information on all the books by J.K. Rowling, we would look up from the other dictionary, which would be constant time. And then for each of those books, we would be able to look up in constant time. So the variable would be the number of books by the particular author, which there's probably no avoiding that, is there? So let's write something to justify that. So have a pause, have a read through of all that, and hopefully we can see how that has met the requirements. Okay, we're going to look at one more. This was from 2024. Make sure you pause, try it yourself, and hopefully by now we've got the idea it's good to actually try these and write something down. I wouldn't have given this question out. People like to come up with a priority queue of dictionaries. And we've got the same problem here with the dictionaries. I mean, if we were to list this out, the dictionary would contain all kinds of extraneous information. We would have job type over and over again, which is not necessary or helpful. Now, problem with this, again, let's imagine we are in the dry cleaning shop. We need to be able to easily identify information about each job and the order in which jobs should be processed. Now, look, it's not made super clear, but if you imagine you're in a dry cleaner, simply knowing the next job you have to do is not enough. You need to, be able to look up other things. An obvious case is when the customer walks in and says, "Hey, can you tell me, is my thing ready?" And you need to be able to look it up. So it's not super clear, but if you put yourself in the position of the person doing the job, you realize this isn't going to work. The priority queue is only going to tell you the next job you need to process. So here, once again, we've got our dictionary, we've said what the key is, and the array containing all the other information. By the way, make sure you do actually write all the other information. Don't just write the words, the other details. Much as I might say that when I'm talking about this, we want to make sure we are hitting the marks for the more picky of the examiner. So then we've got job IDs being added to a priority queue. And notice the successful approaches here, when we combined the ADTs in this one and the last question, were two quite separate structures. So people always want to say, oh, it's an array of dictionaries or a priority queue of arrays of dictionaries, like one thing embedded in another thing. But it doesn't have to be like that. It can be two things which are separate, but obviously they need to share something, so they'll share a key, or one value of one thing will be the key of another thing, as in the last case. Just an aside here, we're told that the store can only process one job at a time. It looks like there are three different options, but really there's only two. Same day jobs have to be done faster, but standard cleaning and deep cleaning, it says they get processed at the same time. So technically it's like, right, we're going to do a deep cleaning job now, so we're going to spend the next 4 days cleaning this thing. Not entirely realistic, but I don't think I got picked up on that. Whatever, I'm just thinking out loud. So we have explained the ADT, and I think we've got everything covered here. We now need to justify why each ADT is required. Now, pretty much done that with the priority queue. We also need to say why the dictionary is required. So we've said here why the dictionary is required. Oh, we said quickly looked up. Let's just add those lovely words in constant time. And I've added a sentence to say, in case the customer inquires. I'm pretty sure that's an okay word. So hopefully that's given you some pointers on how to answer these combinations of ADT questions. Make sure you meet the requirements. So as with everything, read the question over and over a bunch of times before you even start it. and try and come up with a couple of different ideas. Don't just go straight for the first thing that seems right, because it could quickly be you'll think, oh, actually, no, this other thing is much better. So do what House does, differential diagnosis, and then make sure you justify it carefully.